Good day, folks. In this occasion, I will be introducing you to a laboratory technique called Ingenhousz Experiment. And this experiment is named based on its inventor, Jan Ingenhousz himself. He was a Dutch-born scientist and physician, and he worked as a physician in London at around 1765 until 68. And Ingenhousz was an early proponent of variolation, or the inoculations against smallpox through the use of live unmodified virus taken from the patients with mild cases of the disease. In 1768, he traveled to Vienna to inoculate the family of Austrian Empress Maria Theresa, and subsequently he served as her court physician. And later, in 1770, he got interested in plants after a meeting with Joseph Priestley, a scientist from England who works with the plants, and he conducted a study on plants for several years after that. And after returning to London in 1779, he published the results of his study in a publication called Experiments upon Vegetables, discovering their great power of purifying the common air in sunshine and of injuring it in the shade and at night. The English chemist Joseph Priestley had already shown that plants restore to the air a property necessary for animal life. And through his experiments, Ingenhousz found that 1. Light is necessary for this restoration or for the photosynthesis. 2. Only the green parts of the plants actually perform photosynthesis. And 3. All living parts of the plant damage the air through respiration, but the extent of the restoration by green plants far exceeding its damaging effect. Now, you can read the publication by clicking on the link in the description below. Alright, so now I will show you two versions of Ingenhousz experiments. One, which is using the tools can be found in the laboratory, and the second one is by using the tools that you can find at home. Okay, so in front of me now this is hydrilla inside the 1 liter bigger glass, and over here for the setup I need a bigger glass about 500 milliliter, and then 1 funnel, and also 1 test tube. I need to put the funnel inside this glass beaker and then the test tube above the funnel. In order to do these experiments, you need to put the hydrilla underneath the funnel. You must do it under the water. So let me show you how. I will put this 500 milliliter beaker into the water, submerge it completely, and then take some hydrillas, put it in the beaker, and then take the funnel and capture all the hydrillas inside. So make sure there is no hydrilla that is coming out of the funnel, like this. Okay, so next you take the test tube, and then you need to tilt the setup that you already have under the water, and then make sure that the test tube is completely with water, and then fit it into the top of the funnel like this. And you see there is no space that is occupied over here with air, and this is how it looks like in the laboratory setting. Okay, now how to prepare the one that you can do at home by yourself. All you need is these 2 bottles and also the hydrilla itself. The hydrilla you already got it from the kit, so make sure you have it ready. And then for the bottle, you need the one that is a 1.5 liter and one that is 600 milliliter. All you need to do is cut them, so you get something that looks like this. So this is the actual height. Remove this part, and then you cut it again this much. And for the 600 milliliter bottle, you just cut it like this. All you need to do, this one, remove the cap, and then later inside the water you put this small one over here, and then close it with a body part of the smaller bottle. Okay, so again, the same as the laboratory setup, you have to do it under the water. Just take the cut off the biggest bottle and then completely submerge it in water, and then put this the hydrilla into the top part of the smaller bottle, and then submerge it here so it looks like this. And also make sure that no hydrillas is protruding from the bottom side. And then you take this one, the body part of the smaller bottle, into the water. Make sure it's completely taking up the water, and put it above the top part of the smaller bottle, which is capturing or which is closing the hydrilla. So it looks like this. Well, because this setup is not perfect, then there will be probably some air spaces inside the bottle, and that is fine. So on my left side, I have the setup that I made using the laboratory tools, the beaker glass, the funnel, and also the test tube. While on the right side of mine, I have this one that is made out of leftover bottles. Now you see the difference. This one looks really nice. There is no air space over here, and it's completely filled with water, with the beaker glass. But this one, you see on the top there are some kind of water spaces, some air bubbles on it, and also water level might increase as the time passes, because the bottom part over here is not completely closed, so there might be some water escaping from the body of this smaller bottle into the outer one. And all you need to do after this is look carefully at this setup and see if you can find any air bubbles that has the size of a needle. That is the oxygen that you need to observe.